A Beechcraft 200 aircraft had just taken off, preparing to carry out a charter flight across Australia. Neither the pilots nor the passengers had any idea that just a few minutes later, communication would be lost. The aircraft would become unresponsive, drifting unchanged through the night sky for hours before ending in disaster. What exactly happened on board this plane? This is the story of Australia's ghost flight, the Super King Air 200 incident. On September 4, 2000, a Beechcraft Super King Air 200 aircraft was scheduled to depart from Perth Airport in Western Australia on a charter flight to Leonora. On board were 1 pilot and 7 passengers, all employees of a mining company returning to the mine site to resume work. That afternoon, the weather was warm, and the passengers arrived at the airport around 4 p.m. local time. The pilot, aged 50, held only an air transport pilot license. He had accumulated over 2,000 flight hours, had recently completed certification training for the Beechcraft Super King Air 200, and had logged 138 hours specifically on that type. According to reports, he was considered highly professional in his flying, strictly following checklist procedures. Eyewitnesses who saw him before the flight said he appeared alert, in good spirits, and showed no signs of any health problems. After meeting with the pilot, one of the passengers asked if they could sit in the front co-pilot seat to get a sense of how a commercial flight was operated. The pilot agreed, giving a brief safety explanation and stressing in particular not to touch any flight controls. The pilot had already planned the flight route to Leonora and informed the passengers that weather conditions were favorable that day. Some scattered clouds, no turbulence forecast, and good visibility. The flight was expected to be smooth, cruising at an altitude of 25,000 feet. The pilot then began conducting the preliminary pre-flight checks. Since the airport was relatively quiet at the time, he decided to postpone the engine run-up checks until reaching the holding point on the taxiway. At 18:04 local time, the pilot requested taxi clearance. The control tower instructed him to taxi to the holding point for runway 21. During taxi, the pilot checked the operation of the aircraft systems and found no abnormalities. Upon reaching the holding point, he performed the engine run-up checks. This procedure ensures that critical safety systems are functioning properly before takeoff, such as the automatic feathering system, which automatically adjusts propeller blade angle in the event of an engine failure, and the rudder boost system, which helps the pilot maintain control if asymmetric thrust produces excessive yaw. All tests were completed successfully. The pilot confirmed that the pre-takeoff checklist had been fully carried out and once again checked with the passengers to ensure they were ready. At 18:08, the tower cleared the aircraft for takeoff from runway 21. At 18:09, the aircraft departed smoothly, bound for Leonora. As it climbed through 1,200 feet, the pilot contacted Perth Departure Control and received clearance to climb to a flight level of 13,000 feet. At 18:15, as the aircraft climbed through 7,500 feet, the pilot switched to Australia's regional air traffic control, Melbourne Centre. The controller asked whether the aircraft could reach 16,000 feet within 36 nautical miles of Perth. The pilot clearly replied that it could. ATC then cleared the flight to continue climbing to 25,000 feet with the condition that it must reach 16,000 feet before leaving the 36 nautical mile limit from Perth. During the climb, the pilot engaged the autopilot system and set the altitude selector to the standard pressure altitude of 25,000 feet. At this point, everything was operating normally. The pilot's responses to ATC instructions were appropriate and expected. By 18:20, the pilot received further instructions: cancel the current standard instrument departure procedure and proceed directly to the Deborah waypoint. This shortcut would allow the aircraft to join its planned route more quickly. The pilot clearly acknowledged the instruction and adjusted the flight path to fly directly to Deborah. This transmission was the last complete and clear radio communication made by the pilot. The Beechcraft 200 business jet was on course toward the Deborah waypoint, continuing its climb as it approached the planned cruising altitude of 25,000 feet. However, air traffic controllers observed that the aircraft did not level off at 25,000 feet. Instead, it kept climbing, exceeding the assigned altitude by 500 feet. This may have been a pilot oversight, but it already represented a flight safety risk. ATC therefore requested the Beechcraft 200 to confirm its current altitude. The pilot's response was simply stand by. At that moment, there were no other aircraft in the airspace above, so controllers informed the pilot that he could request a higher cruising altitude if needed. But after that, there was no further response from the aircraft. To maintain airspace safety, controllers notified the Beechcraft 200 that they had reserved the altitude block between 25,000 and 27,000 feet for the flight and asked the pilot to confirm if he was still on duty. The aircraft, however, continued to climb, passing through 26,500 feet. Over the next 8 minutes, the Beechcraft 200 transmitted a total of 8 open microphone radio signals, yet no words were spoken. Only the sound of heavy breathing, faint alert tones, and the background roar of the engines could be heard. It was now clear that this was no ordinary pilot error. Something was seriously wrong on board the aircraft. Air traffic controllers repeatedly attempted to establish contact with the Beechcraft 200, providing alternative frequencies for communication, believing the aircraft might be experiencing a radio malfunction. But this did not resolve the situation. ATC continued to receive open microphone transmissions from the Beechcraft 200, mostly the sound of heavy breathing, with occasional indistinct words. By this time, the aircraft had climbed to 28,500 feet. Controllers cleared the surrounding airspace and instructed all other flights on the same frequency to remain silent and on standby. ATC then requested the Beechcraft 200 to activate its transponder's ident function, a radar identification feature. If the pilot complied, it would confirm that the crew still had control and could hear radio transmissions. But the ident signal was never activated. Soon after, the Beechcraft 200 transmitted one more open microphone broadcast, lasting nearly 4 minutes. This was the final recorded transmission from the aircraft. After that, the plane continued on course toward Leonora, still climbing higher into the sky. At 19:02, radar contact with the aircraft was lost. At that time, the plane had drifted northeast, 218 nautical miles from Perth, cruising at an altitude of 32,500 feet. The Beechcraft 200 continued silently, holding a heading of 050 degrees, cruising across the Australian sky. Air Traffic Control reported the abnormal situation to the Australian Rescue Coordination Centre, which immediately launched a response. The first priority was to confirm the aircraft's exact position and, if possible, visually identify it to better understand its condition. Rescue authorities learned that a nearby business jet was in the area and requested it to intercept the Beechcraft 200 for a visual inspection. Guided by ATC vectors, the business jet flew toward the assigned airspace. Before long, the crew reported that they had established visual contact with the Beechcraft 200. At 19:33 local time, the business jet climbed to 34,300 feet and reported that the Beechcraft 200 was maintaining a stable cruise on heading 050 degrees at the same altitude of 34,300 feet. After approaching the Beechcraft 200, the business jet reported that its navigation lights and strobe lights were on. However, there were no visible lights inside the cabin, nor any signs of activity from the crew or passengers. They also noted that because of the glare from the strobe lights and the darkness of the night sky, it was difficult to clearly observe the cockpit or cabin interior. Once the visual inspection was complete, the business jet had to depart and continue with its scheduled flight. The Beechcraft 200, meanwhile, continued flying for another 2 hours, still maintaining its 050-degree heading while gradually beginning a slow descent. By 21:35, the aircraft had descended to 25,000 feet. Air traffic control directed 2 more aircraft to intercept and track the drifting Beechcraft 200. The Australian Rescue Coordination Centre requested assistance from the Australian Defence Force. However, after assessment, the military concluded that it would not be possible to deploy fighter jets in time to intercept the aircraft before its predicted fuel exhaustion. When the 2 assigned aircraft finally reached the Beechcraft 200, they confirmed it was at 25,000 feet, descending steadily at a speed of about 200 knots. The crews attempted to contact the Beechcraft's pilot using the International Emergency Frequency, but received no response. They then closed in for a further visual inspection, reporting once again that the aircraft's external lights were still on, but the interior of the cabin remained unobservable. The 2 aircraft continued to accompany the eerily silent Beechcraft 200, trying both via radio and by attempting to signal through the cockpit windows to attract the pilot's attention. This strange escort continued for 1 hour and 35 minutes. By that time, the Beechcraft 200 had already crossed most of the Australian continent and was approaching the country's northeastern coastline. At 23:10 local time, the Beechcraft 200 continued its steady descent, reaching 5,000 feet. At that moment, one of the tracking aircraft observed the Beechcraft make a sudden 90-degree left turn, immediately followed by a rapid descent. Eventually, it crashed 65 kilometers southeast of Burkitt. The aircraft disintegrated upon impact, and there were no survivors. This crash raised a number of puzzling questions. It was clear that both the pilots and passengers became incapacitated, but the exact cause was not certain. Because the aircraft was not equipped with a flight data recorder or a cockpit voice recorder, it was very difficult to determine what exactly happened inside the cockpit during the flight. Recordings from air traffic control offered some clues, showing how communication gradually deteriorated as the flight progressed. The most likely cause of the crew's incapacitation was hypoxia, a lack of oxygen in the cabin. This could occur if the pressurization system or the supplemental oxygen system failed or was unavailable. In the Beechcraft 200, engine bleed air is used to pressurize the cabin. This bleed air is controlled by the pilots through bleed air switches. Each engine has its own switch with 3 positions: on, environmental control off, and instrument and environmental control off. When the switch is set to on, bleed air is routed into the pressurization system. When set to either of the other 2 positions, no bleed air is supplied. Since these switches were destroyed in the crash, their exact positions at the time could not be determined. However, investigators found that the left engine's bleed air control valve was in the closed position, while the right side valve was open. This may indicate that the left side control switch had been set to the environmental control off position, or that the valve had closed on impact, as it is spring-loaded and may have snapped shut from the shock. Even in this condition, with only one bleed air valve open, in theory, the system should still have been able to maintain cabin pressurization up to an altitude of 31,000 feet. Therefore, while this may not have been the primary cause of the accident, it could still have been a contributing factor. Another critical system is the cabin pressure controller. This device allows pilots to set the desired cabin pressure. It also includes a dump function, which can release cabin pressure if needed, for example, in the event of smoke in the cabin. However, if this switch had been mistakenly left in the dump position, the cabin would not pressurize. When the cabin altitude reaches 10,000 feet, the system triggers a visual high cabin altitude warning to alert the pilots. However, it should be noted that this warning is not accompanied by any audible signal. Investigators therefore concluded that, under high workload or stressful conditions, this light warning could easily have been overlooked. As for the oxygen system, the crew and passengers each had independent supplies. Oxygen would only flow when the left side handle was pulled, while the right side handle controlled the supply of oxygen masks in the rear cabin. The reason hypoxia was judged to be the primary cause was the pilot's behavior during communications, combined with the complete lack of response from passengers later in the flight. When analyzing the exchanges between the pilot and ATC, the pilot displayed typical symptoms of hypoxia: delayed recovery, slurred or unclear speech, and heavy breathing. If the cabin was not pressurized and no supplemental oxygen was used, these symptoms would be expected. At a cruising altitude of 25,000 feet, the time of useful consciousness is only about 3 to 5 minutes. At 30,000 feet, that time drops to less than 2 minutes. Investigators ruled out the possibility of toxic substances, smoke, or fire. Autopsies also found no evidence of carbon monoxide or cyanide poisoning. In addition, although the oxygen system was damaged in the crash, it remained largely intact. One of the pilot's oxygen masks was still connected, though it is unknown whether it had been used before incapacitation occurred. In the passenger cabin, the masks had deployed, but there was no evidence to suggest that they had been used. In the end, the Australian Transport Safety Bureau concluded that the crew and passengers were most likely incapacitated by hypoxia, caused by a loss of cabin pressurization. The most likely explanation was that the bleed air valves had been incorrectly set before flight. However, this could not be definitively confirmed since key systems were destroyed in the crash. As for the final cause of the crash, it was determined that the left fuel tank had run dry, causing the left engine to shut down. Without manual intervention or fuel transfer, the left propeller entered a windmilling state, creating powerful aerodynamic drag. The autopilot was unable to compensate for this asymmetric thrust, causing the aircraft to yaw and roll left, which ultimately led to the crash. Following the accident, several safety improvements were implemented. 1. Air traffic control emergency checklists were updated to include hypoxia response procedures. 2. A recommendation was made that all aircraft operating at high altitudes must be equipped with audible warning systems. 3. Pilot training now places stronger emphasis on the immediate use of oxygen and on recognizing the symptoms of hypoxia as key measures to prevent escalation of such situations.